Every morning, millions drop a high-dose synthetic vitamin C tablet into a glass of water, drinking it to bolster their immune system and support collagen. Yet this rigorous supplement routine often coincides with persistent joint stiffness, lower back aches, and a profound surge of fatigue that hits by mid-afternoon. Most attribute these symptoms to aging, high-stress work weeks, or poor sleep hygiene. Research suggests a different cause. Megadosing synthetic antioxidants can trigger the liver to manufacture microscopic, jagged structures that accumulate within your tissues. Recovering your energy levels requires understanding how the liver processes a chemical surplus and the specific byproducts that result from high-dose supplementation. The liver serves as the primary hub for nutrient processing, screening every compound that enters the bloodstream before it reaches the rest of the body. Because vitamin C is water-soluble, the body lacks a long-term storage mechanism. Any excess beyond immediate metabolic needs must be broken down and excreted. Consuming 1,000 or 2,000 milligrams of synthetic ascorbic acid in a single dose rapidly exceeds the body's absorption threshold, flooding the liver cells. To clear this surplus, the liver activates specific clearance pathways, where the excess ascorbic acid is enzymatically degraded and its carbon rings are separated. A primary result of this degradation process is the formation of oxalic acid. This acid possesses a high affinity for calcium. When the two meet in the bloodstream, they bind to form solid, insoluble crystals of calcium oxalate. Frequent high-dose supplementation effectively keeps the liver in a state of constant oxalate production, leading to a steady accumulation of these crystals in the blood. Once formed, these crystals move through the circulatory system, eventually settling in areas with slower blood flow. These sharp structures often deposit into connective tissues and joint capsules, where their physical presence triggers localized, low-grade inflammation and persistent discomfort. Beyond the joints, these oxalates can also move into the intracellular space, eventually reaching the mitochondria. The geometric structure of these crystals allow them to cluster along the mitochondrial membrane, physically obstructing the transporter proteins that ferry NAD+ cofactors into the organelle. Without a steady supply of NAD+, the internal electron transport chain lacks the necessary inputs to function. Energy production stalls, and the cell's ability to synthesize ATP drops significantly. The heavy exhaustion felt in the late afternoon is the biological result of these crystals physically interfering with your energy production at the cellular level. Reversing this accumulation requires a shift away from isolated synthetic molecules in favor of complex nutrient structures the body can recognize and regulate. The first step is replacing synthetic ascorbic acid with whole food vitamin C complexes, such as acerola cherry or organic amla extract. In whole foods, vitamin C's bioflavonoid bond prevents rapid enzymatic breakdown into oxalates. Next, a citrate flush with potassium citrate or lemon juice clears the system. Citrate outcompetes oxalates for calcium, preventing new crystals and keeping existing oxalates safely excretable. Finally, ensuring optimal levels of bioactive vitamin B6 helps the liver steer glyoxalate metabolism toward harmless pathways, further reducing internal oxalate production. Adopting these three steps stops the internal accumulation of crystals, allowing the joints and mitochondria to function without physical obstruction. Effective supplementation depends on respecting the body's metabolic pathways, rather than simply increasing the dosage of isolated chemicals. By aligning your habits with these biochemical realities, you can clear your metabolic pathways, protect your cellular energy, and reclaim your optimal biological performance.